In section 26, we're looking at interpreting linear models. So if we look at the first model here, a team of painters is hired to paint the exterior of a museum. The total cost C in dollars incurred by the museum for H hours of painting is given by the equation C equals 290 plus 190 or 155H. That's what's called a linear model. What makes it linear is we have two variables and we also have a rate of change and an initial value. So what we're asked to do is kind of much of the same we did before, but there's an additional piece that we're going to try to interpret here. This is a team of painters is hired to paint the exterior of the museum. The cost, so let's set up our function here. Total cost C in dollars, so that's that guy right there, incurred by the museum for H hours of painting is given by that equation. So again, we've identified where our output is, that's the C value. We've identified our input, which is the H value in hours. What we want to know is what does the 290 represent within the context of the scenario. So that's our initial value, and I know that because it's not the number that's attached with the input. That number is 155. So we know that by hiring these painters, they're going to charge us $290 plus $155 for every hour that we work. So what does the 290 represent? The painters charge $290 before any work is done. So this could be supplies, it could be contractual paperwork or something like that, but there's a set fee. They're going to charge $290 and then additional amounts for any additional work. What are the units for C? The units for C, their total cost is in dollars. And then what are the units for H? Well, it's H hours of painting. So our hours here, or H would be hours. What are the units for the number 155? So again, we talked about that being the rate of change because it's attached to that input variable. So when we find rate of change, we take our output over our input. And so our units for that will be dollars per hour. And this is the new component. What does it, the 155H, represent? So I want to explore that a little bit, the 155H, and what that is telling us to do. Looks to me like that's indicating multiplication. So we're going to take 155 times H. Well, we have the units for 155. It's dollars per hour. Oops. Color code this a little better. Times hours. So the hours and the hours will cancel out, and our units that we're going to have left are dollars. So what this represents then is the amount the painters charge for the actual work being done. So we're talking about the money that they're charging when they actually painted the building. So regardless of supplies or any other overhead costs, just the 155H talks about, okay, they worked 10 hours, they charged 15 times 10. So let's look at this chunk of questions right here. So this is number 10 through 13. Dealing with this equation, C equals 105 plus 7/24 m as a measure of total calories, C, in a half bagel covered in m grams of cream cheese. Sounds delicious. So let's see, m grams of cream cheese. So m is our input, and then C is our output. So again, we want to know what are the units for C. It says right here in the prompt, total calories. And what are the units for M? Grams of cream cheese. Question 12, what are the units for the number 7 over 24? So if we got this idea down that it's the output over the input, wrong color, okay, there we go, the output over the input makes things a little bit easier. So that 7 represents the output, that's the number of calories, so it's 7 calories per 24 grams. So then the units are just, regardless of number, it's the calories in the grams here. So we want to know the best interpretation of 24 is shown in the equation above. So really I want to focus here on this rate of change, 7 over 24. So if we've written it like that, it's 7 calories divided by 24 grams. What I'm looking for are any choices here that have 24 grams mentioned. So that's no, that's a 24 calories. There's 24 grams. The number of calories increased by 24 for each additional 7 grams. No, that's not right. The number of grams of cream cheese increased by 24 for every... Okay, so this is kind of where we're at, between B and D. Both of those mention that there's 24 grams of cream cheese. B says a half bagel and 24 grams of cream cheese have the same number of calories. I'm not seeing anywhere in that question that I can determine if that's true or false. So I'm kind of leaning away from that one. Let's make sure that D makes sense first, though. The number of grams of cream cheese increased by 24, so that looks to be true, for every additional 7 calories. That seems to be true. D is the most correct answer because it's showing an increase of 24 grams and 7 calories. And that's what that rate of change is showing us. Now, activity 2, we're taking a look at some slightly different model problems. In these, we have a defined output, a number for our output, and we have 2 inputs. It's still linear because we're still dealing with 2 variables. It's just a little bit different because of the fact that we have a defined output versus a variable output. So again, 22 is our output in this case. Antoine bikes part of the way on a 22-mile trail and walks the rest of the way. So he's going to spend B hours biking. So I see that in that equation right there, that part of the equation right there in that term. W hours walking, so that's 3.5 W. The trip is modeled by the equation 16B plus 3.5 W equals 22. We want to know what are the units of 22 in the equation. Well, it says it right there. If you can see it. There we go. 22-mile trail. So the 22 is in miles. What are the units of W? Well, he walked W hours, so it's hours. 3 says, what are the units of 3.5 in the equation? Because it's attached to one of our inputs, which in this case is W, we know that that's going to be a rate of change. So I'm trying to figure out the rate of the units of the output over the input. So again, we know that miles is an output, and our input is W, which is hours. Miles per, let's make that better, miles per hour. So that's our unit for 3.5 in the equation. What that means is he's walking at 3.5 miles per hour, which seems reasonable. Using correct units, explain what 3.5 W represents within the context of the scenario. So not just 3.5, but that whole term 3.5 W. So what we're going to have is miles per hour and then W we've said measures hours. So what that's going to give us then is miles. So I know that term represents miles. We want to know miles of what? Because it's not the total miles, that's 22, something less than that. So 3.5 W, we talked about the W representing the walking. So it's the rate that he's walking times the time that he's walking, so it's the miles he spent walking. And then 5, what's the meaning of 16b in the equation? So let's think of it this way. If we have these units here, we already know that 22, the units are miles. We discovered in number 4 that the units for 3.5 W are miles also. So if we just rewrite this equation, we've already talked about miles and miles and something else. So if we're going to add these two quantities up on the left-hand side and on the right-hand side we're going to get miles, then both of those quantities had to also be in terms of miles or some kind of measure of distance. You can't add time and distance together and get distance. It just doesn't make any sense. So we know that 16b is probably going to have like units and will likely be called miles. Looking at my choices, I think I can get rid of choice B and choice D because they don't mention miles as just the only unit. Here we have hours, and here we have miles per hour, not specifically miles. So between A and C, A says Antoine travels a total of 16B miles, maybe, or Antoine bikes for 16B miles. Well, the total miles they already told us was 22. He's on the trail, the 22-mile trail. So no, it can't be that. Looks like C is the best choice because you take your rate times the time, and you get the distance that he's traveled.